start our first presentation. This is going to be from Chris McFarland from Intel, talking about some work we've done on implementing MicroPython in UEFI.
Thank you, Brian. So, as Brian said, my name is Chris. I sit in the Shanghai office in our PSI team, core UEFI team. I work very closely with Brian. We're on the same virtual marketing team, business planning and marketing. Today I wanted to talk about basically what started as an engineering science project, and as many engineering science projects start, has grown into something much more. Basically, we're looking at implementing MicroPython as a UEFI engine as well as a UEFI test framework. We'll be talking about MicroPython itself, what is its history, what's the background on it as a project, how we're implementing it inside EDK2, what is the test framework that we're looking at, and some details about that, as well as some future work that we're doing and possibilities. So MicroPython is a Python 3 variant that's been optimized to have a smaller memory footprint, better performance, and be somewhat more extensible than CPython has been in the past. We want to describe the details of the project, some of the metrics. I can't describe a lot of the metrics because we don't quite have those yet as we get into the implementation, as well as some future plans for a test framework, as well as some other plans around possibilities to use Python beyond actually just as a test vehicle. So what is MicroPython? Basically, it's a high-level language that's been very popular in... Sorry. Don't do that. Very popular in academia as well as industry. It's kind of a cross between a lower-level language like C as well as a scripting higher-level language such as Ruby, Run Rails, something like that. Very popular in classes, in undergraduate classes, being taught as a basic language for people to understand. We find that a lot of newer engineers, newer recent college graduates are very familiar with Python and very able to be quickly brought up to speed and be productive. CPython has been part of UEFI for many years, but based on our experience, and please let me know if you have any different experience, but we've seen that CPython hasn't been used very much. And based on our research, we found a couple of reasons for that, being basically it doesn't perform really well and has a fairly large footprint in the runtime, has no direct access to most EDK2 resources, doesn't have any access to hardware resources. It's kind of just sitting there off on its own in the shell, not usable. And it has a lot of shell dependencies. Some of the features of MicroPython itself, it's a very lean implementation. It was started by a professor in England, Damien George at the University of Cambridge, and his students. It's been aimed at microcontrollers in small constrained environments, so it's actually fits very well with what we want it to do in this context. It's a completely open source project, as we like. It's on GitHub, available to anyone to start to use. It's under the MIT license, so it's very accessible and reusable and extensible. Currently has over 4,900 stars and 1,100 forks. So to put it into EDK2, you can see with the diagram here, current CPython, these diagrams are kind of hard to tell the difference, but you can see that the CPython is a fairly large footprint and makes use of a lot of the standard C library and other things that have to be there, and it needs those to be able to do anything under the shell. Whereas when we implement with MicroPython, it brings a lot of its own implementation in and has less dependency upon the standard libraries, and the footprint ends up being much smaller and be faster execution, smaller footprint. So some of the features that we bring along: provide scripts You can use UEFI and EDK interfaces available in the shell. We plan to make it accessible under Dixie as well. Possible implementation extensions in the future to make it available under PEI as well. It has hardware level access built in so that you can use it as a test framework to be able to get access to the deeper levels of the hardware to be able to test and validate. It also offers the basic interpreter as well as a native interface that you can use. Further, it does provide support for native code or inline assembly code that you can put into your test scripts, which gives you more flexibility. One note that we wanted to bring up, there are small differences between the MicroPython and Python 3 language that you will need to take into account when you start either writing scripts or converting from your current usage. All those are documented on the website and clearly documented. Some of the usage we see, I'm not going to go through these in particular order, but one of the biggest supports we see is for UEFI CPython scripts after conversion to 3.0. So if you do have a use case currently using CPython, it's fairly straightforward to convert those over to 3.x, currently at 3.2. We also see a very good use case for replacing DOS tools or legacy applications. We know a lot of medium to smaller customers are still dependent in their factory upon DOS scripts for provisioning, manufacturing steps, as well as validation and verification of both the BIOS itself as well as OS level. So we think that this is a very good fit for being able to help them as we move forward and kind of step away from the legacy DOS applications support, which, as we all know, is coming in a few years. So what is the test framework? Basically, why do we want to create a test framework? It allows the existing tools that we have, the scripts, everything that people have invested time in over the last few years, to be able to reuse those, move them into a Python environment, and be able to put them into an actual framework where they can script that execution and have actual intelligence around the scripting. We found few standard available automated test tools or frameworks that work in the EDK2 community right now that are valuable and useful for new feature development and validation. So we wanted to bring something to the table and contribute something that allowed the test engineering community to have better access to tools, better access to be able to write some sort of scripted automated testing utilities that didn't depend on deep level C knowledge and deep level EDK2 knowledge. So some of our goals were to improve unit test capabilities, allow engineers as well as test writers to be able to quickly write test cases that executed at the level of the unit test, and be able to create harnesses, test harnesses, if you will, around the actual validation and unit testing. We wanted to, as I said, reduce knowledge requirements for EDK and C to be able to allow more engineers into the fold to be able to write quick test cases and to improve the validation surface. So some of the properties have scripts and libraries for MicroPython and UEFI. Basic scripts, basic libraries are supported. The good thing about MicroPython, it is extensible. So if you find something that's not there, it's very easy to add it. We'll provide a set of convenient UEFI abstractions for accessing some of the deeper level of structures. It's designed to simplify firmware, unit testing, as well as development. Hopefully it will remain lightweight and not be a heavy burden, as we found CPython can be at times. So, and we want it to be very useful and cover a lot of different use cases. As I've said, it involves both testing and simulation, as well as the end user factory environment. So a lot of target use cases, including black boxes, white box testing, functional UI, human interface. This is the test framework stack. It's kind of a hard diagram and eye chart to see, but it does kind of give you a small window of view into where we're thinking. So you can see the MicroPython engine at the top. Can be used either in standalone mode or with the scripting engine. If standalone mode, basically you write MicroPython scripts, programs, and it will execute them in the shell. Or you can use the actual scripting framework and be able to write intelligent scripts that execute tests and perform functionality based on the results of those tests. So, if you have a failure, it can call that failure out and be able to log what the failure is and give you pretty logs, as well as a better understanding of where the failures are, or, conditional testing based on the results of prior testing. So, it just depends on how creative you want to be with the scripting. Some of the future tasks that we have right now, we're about halfway through the implementation of the test framework. We expect to have most of the first phase of what we want to do completed by around June timeframe, June, July. So we need to create the branches for the MicroPython engine and framework. Those will be created in staging branches in the regular GitHub, EDK2 GitHub. If you're interested in working on those and want to help us, we're happy to make that available, and just let me know. I'll be interested in hooking you up with the engineering team. We intend to optimize and extend the current implementation we have of the MicroPython engine. Right now, it's probably about 50% of where we want it to be. It's a basic execution environment, and it does what it's supposed to do, but we intend to add more libraries, and it will probably grow just a little bit. We continue to develop the test framework. It's probably around 25% of where we want it to be in the end for this phase. Python scripts, basic libraries, and asynchronous execution under Dixie phase. All of that's about 50% done. Emulation of keyboards and things like that we need to continue to work on. We plan to put a Python API wrapper for the variables, PCDs, and other protocols. We plan to have full APIs for the common operations such as verify, wait, inputs, capture, screen capture, things like that. And as well as basic test case libraries that we will take some of our test cases and be able to create just basic tests that we'll put into the test framework that you guys can extend upon. And as I said, we expect to have the first release around early Q3, probably July timeframe. And that's it. A little quick, but any questions? Good, you'll use up more of my time.
This one is a little better. Since you already have it, we'll start with you.
It's on. There we go. So that means we can expect to see at the Plugfest in our later half this year. We might see further.
You'll see a demo.
Okay.
Yeah, we'll have working code and demo at that point. We wanted to bring something this time, but I kind of held back. I didn't want to do a demo this time, but next time we will.
Sure, that'd be great.
So type A, yes.
Mm-hmm.
To the Microsoft table here.
The abstractions that you alluded to.
Yes.
Check the bottom. It may have been turned off by accident. There you were.
Testing.
Testing. There. All right. The abstractions you alluded to, are they pretty much what you covered in the last slide about the variable abstractions and things like that, or were there more examples of abstractions you already have available?
That's the start, yes. That's what we're talking about right now. Now, we have further phases that we want to work on throughout the end of this year that would add more to that, but those are the basics, yes.
Are you at a point in your development where you're starting to have a clear idea what sort of cross-compatibility there is between MicroPython and Python that might execute from a Windows or a Linux environment?
Yes and no. We understand the basics based on the deltas between what MicroPython implements and what CPython implements, but it's complicated by the fact that CPython is still stuck at 2.7.
Okay.
So if you want to take something from CPython currently, you have to upgrade it to 3.2, which is what we're going for with MicroPython. And you also need to take into account the deltas between MicroPython and Python itself.
Okay, that makes sense. Yeah, what I would hope for is something like, if your script uses these instructions, then it's not going to work in the MicroPython environment.
That's all on the MicroPython website, that link that I had right there.
Okay.
You can go there, and it has very good details on the deltas between the actual MicroPython implementation and whatever the spec says.
Okay, perfect, because, sorry.
Go ahead.
Well, I was going to say that, so I'm with the Microsoft Core UEFI team, and over the past year, since we kind of brought it up at the last Plug Fest, we have continued to add on to the unit testing framework that we open sourced on our GitHub. And more we are writing layers to interact with, we are writing Python script layers and libraries that can be included to interact with sort of PI primitives, things like the var store, things like FFSs and things like that. And it would be great if there was some cross-compatibility between these two worlds so that those same libraries could be shared.
I think we can, and I don't see anything that would hold us back from doing that. And
awesome.
And as I said, it's very easy to go look on the MicroPython website. It's very clear what the deltas are.
Cool.
And if we want to work on extending those and removing some of those deltas, I think as an industry we're free to do that.
Yeah, I think our team would be very interested in contributing to the efforts that you're doing.
I'll be here at Speakers Hours, happy to talk to you, and we can see about making sure the engineering teams are talking.
Fantastic.
Did you want to talk?
Oh no, we've got like plenty of time. So any more questions?
Felix.
So, on one of the diagrams at the end of the presentation, the MicroPython was on top of stdlib. So, are you planning to remove stdlib dependency, or the interpreter will still be dependent on stdlib?
Right now, we still have some dependencies, but there are much fewer than CPython. So, we want to remove as many dependencies as we can upon standard live and have as much self-contained as we can, but we won't be able to get rid of all of them. We know that.
Because I think the library itself depends on shell, and then you said you want to remove shell dependency.
Yes. Yeah.
And do you know what subset of standard Python library is going to be available as a part of MicroPython?
I have the list. I don't know off the top of my head, but I can get you the list. Yes.
Thanks. And maybe a suggestion. You said you're working on this test framework. Then one part is, of course, the EDK2 abstractions, but then there is like a test harness, like how to run the test, how to report the errors. And it probably would be nice before even implementing it, if you have an idea about the interfaces or the model that you want to support, to maybe to share it with the community, because maybe even there are plenty of available Python unit testing framework, maybe some of that.
Yeah, more than happy to talk to you about it. If you have something that you think intersects with what we're doing, we'll be happy to take that into account. And if you have input, want to have input on the design process, I'm more than happy to take that back to the engineering team as well. We're early enough in the process now that everything can still be adjusted very easily.
A comment on that is that's why we have a plan to put this into the EDK2 staging branch before finalizing it, because we've seen a lot of other work done, like the HTTP networking, for instance, was done in a staging branch and then migrated over into the main GitHub. And so we think that and when we do that, Chris, I don't know how much you elaborated on this, but when we do the initial staging branch, it's going to be the entire thing. It's going to be the stuff that will eventually go back to MicroPython and MIT license, plus what we're going to be developing as that common test framework. So that way we have a chance to clean it up before we make that contribution back to the MicroPython community. That's a big difference in the way that we did that versus the CPython port. So we never contributed that stuff back into main Python. So we were always kind of a variant, and every time a major release would come out, we had to do interesting work to kind of keep it in line, and we're trying to get away from that with the MicroPython.
Yeah, and I had that here. I might have skipped over it a little too fast, but the engine will continue to use the MIT license as it does now. That will be contributed both to a staging branch and EDK, as well as all of that goes back to the MicroPython project itself. The framework itself will use the EDK default licenses that we have, the BSD licenses, and be contributed all in a staging branch, probably created the next 3 weeks, 4 weeks or so. If you're interested in knowing when that is, let me know, and I'll email you as soon as it gets up there, and guys can start taking a look at it.
Last question. Do you know, is it like, for example, there are Python script, Python tools to do automatic conversion from Python 2 to Python 3. Did you explore if there are automated ways to convert generic Python code into a MicroPython?
We haven't looked at those yet.
We've got 2 more questions left.
There was an effort going on to port CPython 3x to UEFI. How is that going on with regards to this?
The effort was looking for people to do it. Currently, we haven't found any people to do it. So my final comments, and thank you, it's a good segue. My final comments were going to be, and I'll just go now with them. If you as a company or an individual see some worth in CPython continuing on and being updated to 3.x, please come see me in speakers hours or after this. I'd like to understand your position and reasoning, and maybe we can upgrade the possibility of getting CPython upgraded. But right now, as I said, we haven't found a home for CPython. We haven't found anybody willing to take on responsibility for getting it upgraded to 3.x version. So unless you think you really need it, it may be deprecated at some point.
All right, last question. We already have it.
Okay, yeah, I hate to keep pinging back and forth. I was curious, is this a standalone framework? Is it designed to work with SCT? Does it have interfaces into SCT or out of SCT, calling conventions back and forth, or?
It's standalone right now.
Okay.
But the design, as I said, is extensible so that it can be integrated with SCT. That's one of the further phases as we've laid it out. Right now, what we first deliver will not be integrated with SCT.
Okay,
That doesn't mean you can't call SCT tool tests from it. It's just not highly integrated.
Okay, so it's designed for like one-off unit tests right now.
Yeah.
Cool.
Sorry, one more question?
Yeah, we have time for one more.
Just close to this question, how it will look like. Is it going to be like python.efi and then a script you pass to it, or it's like
right now
it's or something?
Yeah, that's kind of hard to say right now because it's in flux a little bit. So if you have strong feelings one way or the other, please let me know, and I can take that back to the engineering team. But right now it's kind of in flux. It's more of a text-based tool right now, that everything is just coming in as text, as scripts, and there's a little bit of graphical output right now, but they're wanting to expand that. So if you have strong feelings, let me know.
When you say coming into it, into what? Is it
into the interpreter itself, into the engine itself? Basically, it's a command line. Once you get to the script, you run the command line and you feed it the script. You feed the command line the script that you want to run, and it goes and does what it does.
And you started from UEFI shell?
Yes.
Okay, approximately footprint, like for the engine and maybe for the test framework?
I can give you deltas. It's about half the size of an equivalent CPython, and it depends on how much of the libraries you build in. So it's not a fixed size footprint. It's dependent upon your build.
Of course, but the ballpark, megabytes or hundreds?
It's about 128K right now.
Oh, okay, pretty good. Any plans for crypto library?
I'm sure there will be, because we want to integrate very closely with the test tools and the security test tools. We want them to be able to use this as well. So it's not done yet, but there are plans for it.
Okay, thank you.
Okay.
All right, that's our time. Thank you,
Thank you.
Chris.